So today, pleasant morning to one and all. I'm Dr. Sumitra. I'm here to present you about the today's topic of multi-layer perceptron neural network. Perceptron neural network. As far as this multi-layer perceptron neural network is considered, it is an artificial neural network. Artificial neural network that consists of more than one hidden layer. Hidden layers of computational and artificial neurons. Computational artificial neurons. And here it comprises of input layers, one or more hidden layers, and output layer. Consider an example of x1, x2, x3, and here these were the input layers, and these input layers have the hidden layers in such a way we have sigma plus f, this is 4 and this is 5th, followed by we have another layer named as 6 with a sigma plus function, and you have an y output. It is weight of 1/4, which is weight 4, and this input layer is tracked to weight of 1/5, weight of 2/4, weight of 2/5, weight of 3/4, weight of 3/5. Where we have weight of 4/6 and weight of 5/6. Sigma denotes you the summation function, and this is your f is your activation function. The basic notations were as based on the input x1, x2, x3 or the input layers, and we have the hidden layers. The hidden layers as weight of ij is equal to, we have the weight of 1/4, 2/4, weight of 3/4, weight of 1/5, weight of 2/5, and weight of 3/5. These were the weights between the input and the hidden layers. Whereas this weight of jk, which means that hidden layers of weight of 4/6 and weight of 5/6. These are the weights between the hidden layers and the output layer. So the multi-layer neural network is a typically and basic example of for the feed forward neural networks. And the number of neurons and the number of layers consisting of the hyperparameters of the neural networks, which needs tuning. Consider an example. Given multi-layer perceptron consisting of one input, one hidden, and 1 output layers, where the input layer has 4 neurons and the hidden layers has 2 neurons, and the output layer has a single neuron. And here is an example considering x0, x1, x2, x3 and x4. We have x5 and x6. Here are the weights which are connected, x0, and the outputs were x7. This is your output and the output. We have a weight of minus 0.3, 0.2, and here it's connected with minus 0.3. x1 is connected with a weight of 0.3, and here it is also connected with 0.1, and x2 is connected with minus 0.2. x3 is connected with a weight of 0.4. x2 is connected with x5. x2 is connected with x6 with 0.4, and here x3 is connected to x5 with 0.2, and x3 is also connected to x6 with minus 0.3, and x4 is connected to x5 with a 0.1, and x4 is connected to x6 with 0.4, and whereas x5 is connected to x7. So this is your basic, and whereas x6 is also connected to x7 with a 0.2. So these were the basic inputs. This were the question which is given over here. Based on this input, we can consider x1, x2, x3, x4 are the input layers, input layer neurons, and x5 and x6 are the hidden layer neurons, x7 is your output layer neurons. So now train your MLP. We need to train the MLP by updating the weights and the BIOS in the network. Assumption is based on where we have an assumption. The assumption is based on the learning rate. The learning rate is considered as 0.8. This is your first step, and the second step is we have the input of x1, x2, x3, x4 and the O desired. O desired as 1, 1, 0, 1, 1. This is what the exact O desired is all about. And we need to represent all this given weight in the table, such that have this representation, right? Draw this with weight of W1, x1, x2, x3, the weight of 1,5, weight of 1,6, weight of 2,5, weight of 2,6, weight of 3,5, weight of 3,6, weight of 4,5, weight of 4,6, weight of 5,7 and weight of 6,7, and you have a theta 5, theta 6 and theta 7. These were the BIOS weight. These were the BIOS weight with a representation of 0.2, 0.1, minus 0.3, 1, 1, 0, 1, 0.3, 0.1, minus 0.2, 0.4, 0.2, minus 0.3, and 0.2, 1, 0.4, 0.3. This is x1 is 1, x2 is 1, 0, 1, 0, 3, x4 is 1. Alternatively, the first step 1 is all about calculate the input and the output in the input layer, in which we need to calculate the net input and output calculation with the input layer, input of I and output of I, with the input and output layers, input I and output I. So input layers were x1, x2, x3 and x4, 1, 1, 0, 1, 1, 1, 0, 1. Exact output should be here. So the step 2 is all about calculate the net input and the output of the hidden layers. So this is what the second output layer and hidden layer and the output layers. So considering the unit I, where we have a net input of input I and output of Y. So x5 is considered, and I5 is equal to x1 into W15 plus x2 into W25 plus x3 into weight of 35 plus x4 into weight of 45 plus x0 and theta 5, which means that 1 into 0.3 plus 1 into minus 0.2 plus 0 into 0.2 plus 1 into 0.1 plus 1 into 0.2, where I5 is calculated with the value of 0.5, and the net output is output O of 5 is 1 plus 1 plus e to the power of minus g5, where 1 plus 1 plus e to the power of minus 0.4 is equal to 0.599. This is what your output 5. Similarly, we need to calculate for i's x6 and x7. x6's final calculation is 1, and the output of 6 is 0.731, and the i7 is minus 0.334, and the output 7 is 0.417. The step 3 is all about to calculate the error using the formula. Error is equal to O desired minus O estimated. So hence, the error for the above network is error is equal to 1 minus 0.417, and hence the error is 0.583. Hence we need to back propagate the network to reduce your error. I hope you are clear with this concept of multi-layer perceptron neural network. Thank you.